Hello and welcome to the Vector Virtual Sessions with the title Measurement and Calibration of AUTOSAR Adaptive ECUs. My name is Stefan Herzog. I'm a Business Development Manager of Vector for the product line Measurement and Calibration. Today I want to show you in the next few minutes how easy it is to get access to internal signals of AUTOSAR Adaptive ECUs. Let's start with my presentation. First, I want to give you a small overview in the motivation part. Why we need measurement and calibration of AUTOSAR Adaptive ECUs? This should be the question here in this area. What are the typical use cases of AUTOSAR Adaptive ECUs if we have a view on it as a measurement and calibration engineer? So, what we need it for ADAS. That means, for example, if we have data fusion controllers we want to calibrate or we want to measure. On the other side, we have infotainment ECUs. And I think the most important part, the communication of vehicle with its environment will be done. Are these all typical use cases for measurement calibration tools? Is it necessary to have this? So, because these are all not typical control algorithms we are using normally with measurement and calibration tools. So that means we have less need for classical calibration. But nevertheless, sometimes we have or it is necessary to get access to the ECUs to measure out parameters or to set parameters, for example, to switch the operation state or the operation mode of our ECU. So it is necessary to get access to these ECUs. So which measurement solutions do exist in general? So first I want to show you the black box method. What does it mean? The black box method means we are just have a look on the network. We are monitoring the network of the communication between the ECUs, like you can see it here. That means we need access to all in the vehicle networks, and additional, the acquisition and interpretation of all available network data is necessary. But in this area, it's not usable for ECU internal communication because we're just tracking what happens here between the ECUs. But normally we want to have a look inside. So that means we only can see with this method what the AUTOSAR Adaptive ECU is sending out to other connected ECUs. The other method will be the white box method. The white box means the measurement and calibration of ECU internal communication. And that's the more interesting part, I think. So that means we get access to the internal structures or states of the AUTOSAR Adaptive ECUs. So the big question here will be, how can XCP be used for this purpose? Because XCP is the most used standard for measurement and calibration tools. And it will be very helpful if we can use the same processes and things with AUTOSAR Adaptive ECUs. Let's jump in. First, I want to have a look on the white box, the black box method. That means the monitoring of communication between the ECUs. So what does this mean? In classical bus topologies-based networks like, for example, CAN, the measurement access is very simple. So because we have here our network and independent on which position I get access to the bus, I always have the same information on all the points I want to measure. So, and it is very easy to add an additional participant to this network. So, for example, a measurement participant. So, and how to do this? So we're just connecting here with our network interface to the bus, and then it's very simple to measure it with the measurement and calibration tool. So if we have a look on Ethernet communication between the devices, so it's a little bit more complicated because the Ethernet communication is a point-to-point connection. What does it mean? We have here two ECUs they want to communicate, they do it here by a point-to-point connection. So, and if this ECU, this antenna ECU, wants to talk with the HPC1 ECU, for example, we have here a point-to-point connection, first to the communication ECU, then we have a switch internally, then the signal goes out here. But if we want to measure the same signal or the signal communication between antenna and HPC1 on this line, it's not possible to do this because the communication will be only done here on the direct way between the two ECUs. So to do this, to measure now the communication between the ECUs, we have to go in the line we want to measure, and we have to cut this line. So if we want to measure the same here, we have to do a second cut here on this position. And then what does it mean if we are cutting this line? That means we have our communication that's normally going on here. And now we are going in our network interface. We are doing inside this network interface, we call it a tab. That means we are collecting the data, and on the other side, we are directly sending the data out on the other side. If we say it, or we can say now we have two point-to-point connections. In the original, it was one point-to-point connection. That means one from here to here and the other one from here to here. So this is necessary to measure the communication between the ECU. Why it's necessary to do this? Why we not can directly access to the bus? Because we have a point-to-point connection and we have a bidirectional sending of our components. That means the switch and the ECU can send at the same time on the bus. And if we have a look here, we have an additional level of both signals. So if this ECU is sending, he knows exactly what he's sending by himself. So if he knows the bus level, the bus pegel of the signal, and he knows his own level he's sending out, he can calculate out the sending of the other one. So, but this is not possible if we are just going in here. But if we're going in with a tab, we are an endpoint and we always can calculate our own signal very easy. So back to our example. So we just cutting the line here and here. Then we using a network interface. We are just going in here with the line 1 to our ECU, to our network interface. We are doing a tap inside this network interface and we are going back with the second line to the communication ECU. The same we are doing here. So you see we need like more or much more connections to our system, like if we are measuring CAN. So but now we are coming to the measurement and calibration of AUTOSAR Adaptive ECUs. We are going now inside the ECUs. Like I told you before, if we are just doing a monitoring of the communication between the ECUs, it's not such easy to see what happens inside. We only can see what the ECU is communicate to other ones. Now have a look inside. So for this, we have 3 different approaches to do this. Approaches because there are no standard at the moment available. So I cannot say you which will be the method which will be used in 5 years as a standard. So at the moment, we have 3 approaches. The first one will be that we have a look here on the different applications running on our adaptive AUTOSAR ECU. And we say this application will be handled like a complete ECU before. That means we are placing an XCP driver inside this application running on the ECU, and then we have a direct communication from our measurement and calibration tool to this application. And we do this by measurement and calibration of objects with static addresses inside here. The second approach will be that we are using our always existing other protocols like the active SOM-IP communication. The SOM-IP communication is normally used for the communication between the different applications inside the ECU or for the communication to other ECUs outside of our ECU. And we are using this, and we want to get out information out of this interface. But for this, it's necessary to understand some IP, and it is necessary to get in the some IP communication as a participant. How this works, we will see later. The third approach will be another additional already existing system. We want to get access to the system by AUTOSAR Diagnostic Log and Trace Protocol, or short DLT. So this DLT protocol is normally be used to getting out information directly of the application for debugging our application. And that means the application is sending out some data, and this data could be then recorded outside if somebody understands the DLT protocol. Let's go in deeper a little bit. For approach 1, that means we want to use our already very good known XCP protocol within individual applications. That means we have to place inside our applications an XCP interface. At the moment, there is no standard for this XCP interface. We have already done this with some customers and it works well, but there is no standard. And we always have to set up a TCP/UDP socket connection then directly to our tool CANape. If we have a second application we want to measure, we need a second XCP interface inside this application, and we need another TCP/UDP socket connection than here. So, but there are differences between the normal use case, the normal use of XCP in ECUs. So what is it? So one will be that we have here the usage of virtual memory in our ECU. So in the past, if we are using XCP or classic AUTOSAR ECUs, we are compiling our software and we are downloading the software or flashing the software to our ECU, and then we have already fixed addresses. This is not a thing we have here inside. So because the application can run or cannot run in the ECU, and if the application is running, they get access to a virtual memory. So we have always different addresses we have to know. How to handle this? This will be handled very easy because we adding some additional part here that if the connection will be set up to the XCP interface, we got a basic address, and out of this basic address we are using offsets to calculate out the other addresses then of our needed signals we want to measure or calibrate. If we are using that, so it's very easy to reuse our XCP implementation we have used since many years. The approach 2 will be we are using already existing services out of AUTOSAR Adaptive. In this case, we are using the service-based measurement calibration method by SumIP. So what does it mean to use SumIP or to communicate via SumIP? We have to be an active participant of the SumIP communication on the Ethernet bus. That means we have to subscribe to the services offered by the ECU in order to get access to this data. That means we have our tool CANape. We are connected by SumIP by a network interface to our SumIP device. And in this case, the good thing will be in no tab it will be available, because in this case we are always an endpoint. So we have an easier measurement hardware setup in this case. So, and we got access then to all the available data which is already defined, or which has to be already defined at the design time. So that means it's not such flexible as the standard XCP we have seen in approach 1 is. So that means we always have to think about what we want to see, and we have to place this in the communication interface of SumIP before we are flashing down our application on the ECU. And the definition or the description of this interface we have to place in an RXML database. This database will be read in by CANape, and then we could get access to this data. Then we could access to signals, to objects, or to structures. How to configure some IP connection in CANape? It's very easy. So CANape offers a separate device tile for some IP. You can see it here in the new device configuration dialog of CANape. There are some additional some IP. All required configuration steps you need to set up this some IP communication is in this dialog described. So you can set up the network you want to use, you can set up the IP addresses, or you can assign the databases. Very easy. And if we have done this, so that means the database is added here. It's very easy to measure the signals and or to set the calibration objects. So it's the same handling or feeling like we had before. We have here in our Symbol Explorer in CANape our device. Then we have here our signals or our calibration objects, and then we can use by drag and drop, for example, we can shift these signals to a graphical window or different other windows we are offering in CANape, and then you're just clicking on Start Measurement, and then you can see or visualize the signals in CANape, or you can record the signals in CANape. The same thing if you want to do calibration, just drag and drop the calibration parameter to a parameter window, and then you can switch the value. Approach 3 means we get access via AUTOSAR, and we are using the Diagnostic Log and Trace protocol, or short DLT, which is coming up more and more in the last time. So what does it mean? The DLT will be normally used to getting out some diagnostic or logging informations out of the application. That means the application is sending logging information. We have placed a DLT module in the middleware of our AUTOSAR ECU. And in this middleware, in this DLT module, it could be that you're using a filter that not all of the signals are sent out then on the communication bus to the recording device or our tool, for example, CANape. So the protocol output and recordings of the ECU internal debug information will be sent out to an external device or tool. So the complete DLT will be specified or is actually specified in the AUTOSAR FOR 1911 document. So if you are interested in it, you can have a look in. What are the advantages of this DLT method? So we are collecting debug information of the application or other software modules. And it's possible to set up some filters or to filter the debug information that we only get the needed informations we want to see at the moment. And the DLT protocol is independent of the bus type. So normally, the Ethernet bus network will be used, or automotive Ethernet network will be used, because we normally need a higher bandwidth because we have a lot of signals normally we want to send out. And so it's not always the best to use then a CAN bus for sending out this data. Let's have a deeper look how it works. So first we have our applications, and here this application sending out their logging messages to our DLT module. The DLT module is being called, we say, to transmit a message, and we are sending the message in a non-verbose mode in CANape. What does it mean, the non-verbose mode? Because DLT supports different modes to send data. There is a verbose mode and a non-verbose mode available, for example. Actually, we are only supporting the non-verbose mode. That means we are not sending some meta information with the data out of the DLT module to our tool. But that our tool then is understanding the messages, it is necessary in the non-verbose mode to add a database where we can add then the missing information which are not on the bus to our messages, and this will be done then directly here on our measurement and calibration tool. So first we are getting the log messages now, then the DLT module could filter or create the DLT messages then the DLT module is sending the messages to the network without meta information, so we are saving bandwidth on our bus because it's not necessary to send all this data, and the missing meta information then will be added by our FIBEX. And then we have the same process like every time we are writing our MDF file. That means we are writing the interpreted informations in the MDF4 format. So the same thing like before for some IP, the DLT could be very easy integrated in CANape. We have some dedicated device tile directly available here. The configuration of DLT will be done always as a DLT endpoint. So it's easier to configure it then. So it's not necessary to set a tab then. The description will be in FIBEX. We have to set up this FIBEX file in CANape. And the signals then, like we have seen it before, are available then in the Symbol Explorer of CANape. So you can use drag and drop to visualize this. And you can use all CANape recorders to record this file. So let's finish my presentation with a quick summary of what we have seen now in the last minutes. So the classical measurement and calibration via XCP is already possible, and maybe I think it will be one of the best methods to do this. So because we have the most flexibility to measure our ECU or to calibrate our ECU. So, and we always can reuse an already existing workflow very easy. The active network communication, like some IP, is a very nice additional method to get access to our signals, but we have to subscribe to the services to request the ECU informations. And we only can get access to the data which already be defined in a very early development phase of our software. And the last one, we can use the Diagnostic log and trace protocol to get access to our data. I hope you have enjoyed this web session, and if you have questions, we will be happy to answer these questions in the Q&A session. You will get information about the date and the time of this Q&A session by email. Thank you very much. Have a nice day. Bye.